the topic of this meeting is how to build a times model from scratch. So the idea was to start presenting suggestions from people that have used times to develop models from scratch. So the topics can be a bit different, but I think they can offer good ideas on how to actually utilize times when you start building a model and what you can do. So we start off, the structure will be a sort of 10-15 minutes presentation, and then we have 5 to 10 minutes questions after each speaker. And then at the end, we have a session. Hopefully we have enough time to have more questions, or sort of another 15 minutes for overall questions for all the speakers. So you can send your questions via chat during the presentation. I'll try to collect them and ask the speaker, and if you have something more to ask, then you can raise your hand and you can take the floor. So we start with Kathleen first. You can see the title there. So building multi-regional models and experiences with development of models for Canada and North America. So Kathleen, you can start.
George, so good morning or afternoon, depending. So when I was trying to recall how we started, there were two main aspects that came into my mind in terms of challenge, and one is data issue, and the other one is how you deal with multi-regional aspect while we build the Canadian and the North American model. So I will briefly talk about these 2 points. Okay, now it's not moving. Just a brief word about the model itself before we talk about this. So this is the NATEM model, which stands for North American Times Energy Model. So it has conventional time definition with calibration up to 2060, 16 time slice. In terms of region, so we have Canada, which is multi-regional, of course, with 13 provinces and territories, USA with 9 census regions, and Mexico in 1 region. All these models are developed. The USA part is not completely finished, but they are not attached together yet. It is quite detailed, so we cover all energy sector. We have 70 end-use demand in each region. We cover all non-energy sector which contribute to greenhouse gas emission, except LU, LUCF. So at the end, what we want is to be able to replicate greenhouse gas inventories and to model net zero emissions. So this is only to tell you that at the end, we wanted a model that is quite detailed. So we'll focus on Canada for now, so 13 region and 13 region. So how it started. In terms of data, we have energy balance provided by Statistics Canada from all these 13 regions. However, contrary to what you might think, data quality in Canada is not that good. So there's many old, and because of confidentiality issues, so they remove the data from the balance. And there's a lot of inconsistency even within the same organization. So because they work with survey, but they don't do the job of like making this consistent. So you have all kinds of survey that comes and one data there and one data there that doesn't match. So we do a lot of data work, and I will show you in 1 second, before starting to build the model itself. So so do you see my Excel spreadsheet? So you have, for example, for each region, so this is about the size of a typical energy balance. So where you have all the fuels, and in all what you see in yellow are actually the confidential data that were removed and that we try to fill it back. So sometimes it's easy because you have total of 1 fuel for all Canada, or you have this, you have that, but with many additional data sources, we try to fill these all. So when you see green, it means that we are confident about data. When it's red, we are not. So this region, for example, Alberta, is not too bad, but in some other region, it's just a nightmare. You see the refinery in New Brunswick, we don't know anything about it. So you are left with just assumptions and stuff like that. So this is just to say that we spend a lot of time on this, and we do it very carefully. There's no automatic way of doing this. You just need to, to scratch your head, and this become like a giant Sudoku that you try to resolve with by combining all kind of data source. But if you do it well, and at the end there's no statistic difference and all of that, and you make sure, the other important point is to make sure that the inter-regional trade, so each region has a line which is inter-regional transferred. So this is the trade within Canada. So if all this at the end sum to 0, you can start modeling. So, and of course, we complete some balance with national or regional data source, which are most of the time more reliable. So after you do all this, the good news is that if the data work is done, you can start building the model already. So when we started from each of these balance, we started to model it like with this level of complexity. So I don't know, I didn't count the number of views, but there's quite a lot, and there's quite a lot of number in the balance. But because everything is calibrated beforehand, you can have a model running in the first day or first week, maybe, for somebody who is not used to that. So the way, my approach to build a model from scratch is to cover the full balance right away, but in an aggregated level, and then to go to details. So for example, you can start with a very simple technology. So you cover, this is not my model, but just an example I do in the training. So you create one technology for each fuel, for each line of the balance, and then import technologies or mining technology for all the supply side together. And as you detail your sector, and the model will run like this and be calibrated because you cover the whole demand and the whole supply in one shot. And then as you go, you detail your technology for one sector after the other, and you subtract this from the aggregated line, and then you continue like that, and it's solved very quickly. So after that, the only part that remains is the energy trade. So energy trade in North America is really important because there's a lot, and for all kind of fuels, so fossil fuels and everything. So this is quite a challenge, but we can manage. For example, this is the map of oil pipeline. It's not a problem if you don't see the text there. This is the oil pipeline map in North America between Canada and USA. So we model each pipeline by itself, so with a specific technology, with a capacity factor, and so on. Between the main points, so from the first to the destination, but also with the intermediate step. So what we do, so we know, and we want, because in Canada it's very important to have types of crude by types, and which is not given in the main balance. So we want to cover like light oil, heavy oil, bitumen, synthetic, etc., etc. So what we do is that, for example, this is the main Enbridge line that starts from Alberta. So we know how much oil by type is produced in one region, and we know how much of each crude type is taken by each refinery. So by knowing the mix at the first point, and by knowing the mix at the end point, we model the pipeline with its capacity, and we let the model optimize because it cannot go anywhere else anyway. And normally, because there's not that many options, we are able to solve the puzzle of what is going where. And we have some statistics about the flow of crude by pipeline, which is an additional sources, which is not necessarily consistent with the other data, but this gives us an idea of what is traveling from where to where and by which pipeline. So we do this kind of approach for gas, electricity interconnection, refined products. So by modeling by infrastructure specifically and knowing what is leaving and what is entering where, we are able to manage that. So this is why, and this approach is good to be able to connect the two models together, because how you will see, what you will see in the result is that all the oil produced in Alberta are not exported to the USA directly, but it travels to there, to there, to there. And finally, so you will see a lot of oil export from Manitoba, which is this province, to Minnesota or to northeast. So that's what we do. And after that, for USA, just quickly, it's completely the opposite situation. There's no already made balance, very perfect, and so on, already done. But however, the quality of data and the quantity of data in USA is really great. So you spend much less time doing what I've shown at the beginning. You can just use macro or automation of data, and then we compile all data by state, and then we aggregated in 9 census regions. And the only reason is to be able to have, to have less region in the model to minimize solving time, but we are able to provide greenhouse gas emission inventory by state. And by matching all these data together, by doing the USA and trying to combine the Canada, we find sometimes some inconsistency, but the model itself, because we have done the data work carefully, help us to manage that. So a good example is natural gas. So we have natural gas projections here. We have that is also calibrated to national data source. And we have the export of gas that USA is saying will take from Canada. So when you understand that our gas consumption will not increase that much, so you wonder where will go all this gas. So we are supposed it's LNG, but you see by combining some data, you find sometimes some tricky issue to deal with like that. And I wanted to find a map. Mexico has energy balance for 5 regions, but we just do the whole Mexico because we don't have enough information about the trading. And last slide, we also, in some provinces like Quebec, which is my hometown, we do have a disaggregation, further disaggregation at the city level. So we have the Montreal area with 5 zones. And at the beginning, we had tried to model this by a specific region in times, with really like a full region with trading and all that, but it became a whole nightmare to track the flow of materials, because we have also industry in very detailed materials and energy between all these regions. So I decided to remove all that, but demand are specific by region. So you have square meters of houses and heating demand and all of this by region, but there's no trade within this. So, and it is the same approach we took for Mexico. So that's all what I had to say. So in short, a lot of data work and a kind of decision aspect to make in terms of regional trade, whether you do a full region or just different demand by region within your model. So I hope it was useful somehow.
Thanks, Kathleen. 2 questions from Teal. How were the time slices selected, and do you model with full foresight, perfect foresight?
Yes, perfect foresight. Yes, but I do try to do it also because here, especially here in Quebec, they would like to be able to have greenhouse gas emission projection by like there are more simulation mode kind of scenarios. So we do, but by default, they're perfect for site. And time slice, I didn't want to have many time slice. I was afraid of solving time, but when I see the Swiss model with, I don't know how many time slice, I'm encouraged maybe to try to extend that. But it was really looking at the load curve of electricity, the extreme demand. So we make sure, I mean, the season are important for hydro reservoir, hydro dam, data availability and so that. So we could have aggregated the intermediate season, but here what you see in Tiam, for example, but here there's a big difference between fall and spring in terms of water in dams. So this was important. And intraday period, we managed to cover a morning peak and evening peak. So that's the only reason. And of course, because we have so much issue with data that I didn't want myself to try to build all that with many time slices and try to match everything and calibrate electricity price and so on. And I forgot to say, but at the end with our model, the important thing is that we want to be able to cover national, not only national, but also provincial and city level greenhouse gas inventory, line by line and gas by gas. And that's all this data work is also important for. So we can replicate any inventory and with any methodology, because the city level has a different protocol and state and national.
Okay, thanks, Kathleen. So if there are no more questions for Kathleen, I suppose so. Okay, so we can move on. To Olex. Olex is now in Cork. So he's traveling on the other side of Europe. He'll talk about building times models with flexible temporal resolution.
Thank you, George, and hello, everyone. I'll just share my screen. Yeah, so the title of my presentation is Building Times Models with Flexible Temporal Resolution, and I'll keep the presentation very short, and then hopefully that will leave us plenty of time for discussion. And I mostly give some considerations on a high level. So basically, two questions that I attempt to give insight on in this presentation are why flexible temporal resolution is usually difficult in times models. So the difficult is quoted because basically means take time or significant efforts to change. And then what approaches can be used to make flexible temporal resolution easy in times models. And again, easy is quoted because it's easy in some ways, but maybe not that easy in other ways. Before I talk about the time slices, I'll just briefly tell a little bit about myself. So as George mentioned, I'm currently in UCC working on Times Island model, but my bulk of my experience with times comes from my 11+ years in DTU, where I both worked on and with times models like times decay, ETSAP Tiam, times Nordic, etc. I've also taught a master course on times to between 40 and 90 students, depending on the year. So in between DTU and UCC, I've also helped kickstart Energy Modeling Lab. And during that time, I actually developed a time slice tool for the Danish Energy Agency with that purpose of having flexible temporal resolution. And then I also briefly worked in the Danish Energy Agency. So going directly to the topic. In general, times models are quite flexible, as you probably all know it. For example, on the data management side, weather allows quite flexibly and logically to specify data in a sector country focused manner. one collects data in workbooks, normally topic specific, focusing on new technologies, for example. And then this kind of flexibility allows one easily to pop in, pop out data set depending on the focus of the analysis. One also normally uses scenario files to granularly modify assumptions depending on the analysis. And there's much more. For example, in general, times code itself is very flexible. However, what about temporal resolution? It's a spoiler. It's often not easily modifiable. In general, times data tends to be spread across many files in times models. For example, in GRCU times models, there is time slice data in 15 files, probably across multiple spreadsheets. So it's a lot of places to modify if one wants to change time slice resolution. Then another issue is that time slice data tends to be mixed with other data in Excel workbooks. So, if one wants to increase the temporal resolution of the model, one would normally need to extend the table, and that causes some practical issues like, one can introduce errors when extending or moving data around Excel tables. Some formula references can switch, input table can get broken, and so on and so forth. Yeah, and then finally, there is more work in maintaining multiple model versions. For example, if one wants to have two model versions, one with the not that high temporal resolution and one with the high temporal resolution, then having time slices spread across multiple files means much more maintenance work to those files if one wants to change some other data. So basically, one would need to make a change twice in order to get the same model functionality in two model versions with different time slices. So based on this kind of challenges, I have one design suggestion. So for example, approach one. It's basically more or less straightforward. Limit the amount of workbooks with the time slice data. For example, it's possible to have, in general, in the times model, to have all the time slice related data contained in only two files. So those files would be system settings, which includes time slice definition itself, and then a dedicated time slice scenario file, which would contain all the time slice related data for different attributes, process commodities, and as well as duration of specific time slices. And then another practical consideration is that in case one wants to be able to increase the temporal resolution, then those tables should be extendable downwards. So in that case, one could use, for example, VBA to automate increase of temporal resolution based on, let's say, a different aggregation. And in general, this approach of limiting amount of workbooks with time slice data to, let's say, two, or and having them time slice focus brings this following benefits like easier overview, possibilities for automation. In this case, it's also easier to maintain multiple model versions with different temporal resolution because it's basically the time slice specific file which needs to be changed between 2 or 3 or 4 model versions. And in this specific case, actually also the system settings files. Another approach, approach 2, it's basically same as approach 1, but to use an external script or tool to generate dedicated time slice scenario file. So in addition to the benefits of approach 1, one would normally gain lighter workbooks because one would normally remove all the formulas from there, but let the tool export the data. Then, in principle, one is able to utilize various time indexing capabilities, which are present in programming languages like R or Python through dedicated packages. One can also combine a script like that with other tools to generate meaningful aggregations. Then an added benefit is a faster workflow. Normally, it doesn't take that much time to run a script once a desired time slice resolution is defined. And then also a huge benefit is better documentation, because normally that script would contain all the input data, like the original time series, and also information on how those time series were transformed. So it becomes possible to re-aggregate the data to a different resolution. And there's an example of such a script. It's a version similar to the one that was developed for the Danish Energy Agency when I was part of Energy Modeling Lab. And that version was also released open source. Yeah, and just to give you a little bit more insight about that tool, it's basically, it's kind of by functionality, it's split into 3 distinct areas or tasks. One of them is categorization. That's basically finding out which hour in a year belongs to which category, to which time slice category. So for example, in here, an example of categorization would be according to season or month, according to work day, non-work day, and then also hour during a day, for example. Is it the peak hour? Is it not? Then another block is transformation. It's basically finding out how to use the original time series and how to transform them to various times attributes. This part normally will be more specific for a times model, and it's really difficult to generalize it because it will depend on the chosen modeling approach in the model. So any tool would need to be adjusted in that case. And then the last part is printing, is basically making a workbook containing that time slice data. So that was basically it. The only thing I wanted to show you also an example of a single workbook. So basically approach 1, or which can be also done in using approach 2. So basically, this is an example from Times Denmark. And here, different time slice data is spread across different spreadsheets, focusing on a different technology or different sector. So for example, this first spreadsheet contains information about different time slice duration. Then another sheet, for example, this one contains information about availability factors for offshore. And then in this case, it all contains a lot of formulas. So it's kind of quite a heavy workbook, and also normally took a lot of time for Veda to process. And those input tables, they are they linked to the aggregated time slice data. So various time series that are aggregated specifically for this temporal resolution, and plus some other data, which is maybe technology specific, like availability factors that are used to scale this data. So using approach 2, one can kind of avoid all this complexity in a workbook, but rather have it in a script. But then in that case, just to reflect personally on using a scripted tool, is that then one kind of needs to learn a programming language or use a programming language to do it. So for example, the time slice tool that was developed for the Danish Energy Agency, that one is implemented in R. Yeah, that was more or less it from my side.
Thanks, Alex. So Amit has a comment to make. So I think, Amit, you can actually speak directly if you just unmute yourself.
Hi, thanks, Alex. That's very interesting. And actually, I think Pernil had requested at some point, to be able to choose time slice definitions like we choose period definitions. And at that time, it seemed absolutely impossible to me. But actually, why is the time slice definition embedded in sys settings to start with? And that was done because time slices are one of those things that Veda recognizes, like an attribute. So in an FIT table, if you put a time slice in the column header, then Veda recognizes that this is a time slice. But now, like you say, if you really need to change time slices very frequently, then you need to have all of them in a single file. So when all time slices come in a single file, then that first requirement is not there anymore, because you are not going to do that in an FIT table. So I am seriously considering relaxing this requirement. It's just a question of how it fits into the design. But basically, at some point soon, we'll be able to simply select a scenario file and run a time slice. So it will totally use what you have done. The only difference is that you won't even have to change the sys settings. The time slice definition will also stay in the same file. So depending on the scenario that is selected, your time slice will be activated. So that will be very streamlined.
That's really nice. I mean, actually, as far as I remember, at some point, actually, during that discussion with Pernille, I think you also mentioned that in principle, Veda could also do aggregation during runtime. I don't know. Do you have any, provided the original time series are there? Do you have any plans to implement that, or?
I think, like you said about not being able to generalize things too far, I think it falls into that category because either you assume that all your data is available at an hourly level, and then you specify something. So if all the data is available at hourly level, then yes, something can be done. But I think it's too general a problem to be programmed. But we can discuss offline and see if something can be done.
Good. 2 questions from Kathleen. How many questions and how long does it take to solve?
To solve? To solve what?
Yeah, Kathleen, can you open your mic and ask the question? I mean, I think that's easier. Yeah.
I mean, maybe you said it. I didn't hear. But how big is become the model with all these time slices, and how long it takes to solve?
Okay. Yeah. No. So the original times decay model, it used to have, or it has 32 time slices. And that one probably was around 5 minutes to solve. Now with the times island, we are experimenting with other temporal resolution. So much higher than that. But since it's currently, in creation, we don't really know how much the full model will how much it will take time to solve a full model. Yeah. So unfortunately, no statistics on that. But actually, the whole point about having a time slice tool like that is the ability to postpone the decision on for the number of time slices to the point when you have to make it. then if you have it flexibly done, then you can very easily decide to have 16 time slices or 500 or more.
Just one question from my side. You said when you use approach 1, you make your tables expandable downwards. So basically, this is what you have shown in the Excel, right? Being able to actually just use the vertical direction to add extra information when you change your time slices, right?
Yeah.
Yep. And your TS tool, it's basically creating directly input tables that can go into Better, or just input tables that you then need. Yeah.
No. So the idea is to create input tables that directly go to Veda, and so depending on the model size, one may also need to kind of choose between using direct insert tables or just the insert tables. And then if one uses direct insert tables, then probably one needs to, so for example, like in the case of the Danish Energy Agency, one would need to read the names for commodities and processes in order to then include them in the table, in the direct insert table, because you don't use wildcards, but you have to provide all the attribute dimensions. So it's a bit more complicated, but one can do it because programming languages in general normally have modules that can read Excel and things like that. But it's more programming then.
Just one extra question. Will it help the automation when starting from scratch? Do you have all data as time series with the same time index? No.
Come again? I'm not sure I understood the question.
Can you just turn on your mic and ask the question, please? Till?
Sure. Yeah. Can you hear me? Yeah. Till here. Hi, Alex. Yeah, I was just wondering, since usually you have some data in time series, some data just as data points, but usually you also want to change data points during time for some, for example, sensitivity analysis, to, even though if you have just a data point, to give them all the same time index and just copy the data that you have for a point to every year. So all the data would be in principle as a time series. That was an idea I had basically when you're starting from scratch. So you just have a big table with the time index and then all the data that you need in there to serve automation. In a way, I don't know.
Maybe.
Okay.
I'm not completely sure about the design in that case. Yeah, but I mean, also another nice benefit of having it in a scripted tool is that you can just, it's sometimes the data doesn't come in the hourly times, in the hourly resolution. Maybe one is able to get data in a sub-hourly resolution, and then having it in a script written in a language that allows time indexing, also allows aggregating that easily to an hourly resolution, or the one that you need. Yeah. So in general, so my view is kind of, I prefer doing time slice more flexible, and one can do more. And then it's kind of less formulas. So if I need to change something, then I just change it in one place instead of in many cells.
Great. Okay. So thanks, Alex. I don't see any more questions there. we'll have time at the end overall as well for questions. So I think we can move on to Evangelos Panos from PSI. So Evangelos will talk about building a multi-regional model using a single Excel workbook and TFM DINs, direct insert tables. So Evangelos, you can start.
Okay. Share the screen. How much time I have? 10 minutes or less? I don't know.
10, 15 minutes, 15 minutes if you want to reduce the questions. So you can talk for 15 minutes, yeah.
Okay. So this the presentation builds on continues what Oleg suggested, and basically all started in my case when in a project I had to build very large instances of a particular model, the PSI ETSAP model, in terms of regions and time slices. And you can see here, for example, how the model needed to expand in terms of time slices from 288 up to 8,000 hourly resolution for 11 periods, and then or 22 periods, and then 8 regions or 20 regions. And then here you can see about the sizes that we are talking about. It's enormous, it's crazy thing. And then by doing this, I needed to have it in a way that I can maintain all these instances. I needed to have a flexible creation of time slices. That was exactly the same as what Oleg presented, that you have them in a scenario file. But then I saw that there was also one more limitation there, that usually when we build a multi-regional model, we have separate workbooks for every region. And that, to me, it didn't work very well, because these regions often share same process names and same commodities to a large extent. And the second point is that I had multiple points of maintenance. I mean, I had so many different instances of the model with different regional resolution. And then if I wanted to make a change in one, I had to go to the other. Or, for example, here, if I want to change a process parameter for Germany that needs also to be changed for Switzerland, if I have two workbook Excel files, then I had 2 points of maintenance and can create some inconsistency. And the second disadvantage that I have is that I had a lot of replicated information here, and this, of course, had a bad performance when you synchronize, because you have to synchronize so many books. So the solution that I came, it was that I have to aggregate everything, what is common, into a single workbook. I call it here EU. And in this workbook, I just keep all the common region, all the common processes and commodities across the regions. And also I can put in this workbook common attributes of these processes. For example, the capacity, the activity to capacity, or the lifetime, seldom are changing between the regions. And then I used a scenario file, and in this example, a single scenario file, which I had all the time slices. I had all the data definition via DINs. If I wanted specific commodity flows, I used, for some regions, I used the Topins facility. And also, if I wanted to disable some processes, I would just enter a DINs table with process and off, and then this was going away. So I will give you some example. So how this looked in Veda frontend, that was my previous approach, several regions, each one in its own workbook. Now one with the common definitions of processes and commodities, and one with the data. So as you see, I have removed a lot of other scenario files just to keep the example very concise. And this is the contents of the single workbook. I mean, this workbook here. So it just creates the definitions of commodities, of processes, and a normal FIT table with a topology and common attributes. And as you can see here, common attributes are capacity to activity, the peak contribution, lifetime, and etc. And then in the scenario file with the data, which is, I go back again, which is this one here, I use DINs table, oh, sorry. Oh, what happened? Ah, yeah. I use a DINS table in order to facilitate the import process for the definition of the data. Invalid processes was disabled with a process on-off. So, for example, if coal is not an option for Switzerland or Austria, for Switzerland, I disable it. If uranium is not an option for Austria, I disable it, and so on. And for some region-specific additional flows, I used in this scenario file the TFM topins. And here I used TFM topins A because I wanted to declare an auxiliary commodity on the output of a storage process and on the input of a storage process for Switzerland to be able to control some bounds there. And by doing this aggregation, I speed up a lot the synchronization in Venda. So before, when I had multiple workbooks, for this simple example, took 2 minutes and 50 seconds, and now only 1 minute and 20 seconds. So this means, for this simple example, I got a 50% reduction in synchronization. And you can imagine now in these crazy instances which I presented in the beginning, this is quite big. And one may say now that the DINS table are not flexible, and we don't have the possibility to put wildcards or something like this. It is true, but there are two GAMS tricks that I would like to share with you, which can introduce a sort of flexibility when one defines TFM DINS, TFM INS, and also user constraints tables. For this, I'm happy that Amit is here because maybe we find a way to make this a little bit, if it is useful, more integrated into Veda. And I will present the first trick. The first trick, if we look at the DD file, then the set of time slices lists all the time slices one after the other, which is perfectly fine. In GAMS, the GAMS language allows me to use this structure here, this symbol, Abrahams, and then the name of the set, which is the OTS, and immediately I take into this new set, my TS, all the set members here without writing them. This is the first trick. So the use of this symbol plus the name of the time slices. And then the second trick, again, when we look at the time slices set, if we have many time slices, often these are having something, a structure, which has a prefix and then a suffix which varies. If this structure is applicable to your case, in GAMS, we can group this like the structure that you see here, so that we can have the same stem, the same prefix, summer, working day, D, and then GAMS automatically expands the elements between 0, 1 and 0, 8. I don't need to write GAMS, however, because very nicely in insert and DINS table, I can use these structures directly. And I can use them directly from time slices at least. So you see that in this example here, I wanted to define a commodity bound for all time slices. And commodity bound is not defined on the time slice level. So it's not, I cannot write here day, night and get it that. I have to specify one time slice after the other if I want to apply this bound everywhere in all time slices. So instead of writing the time slices one after the other, I just write Abrahams and then, how is called this symbol? I don't remember now in English, this symbol and then the name of the time slice set. And then in Veda, this is retained like that. And in GAMS, DD file is retained like that, but GAMS automatically expands this inside its compilation into all my time slices. I tried to make this also for processes and commodities. So I tried to put that with process and commodity names of the time set, but this is, I couldn't find a way this to work. And here, perhaps, maybe it's not supported or maybe I haven't found it. But for time slices, this works. And this is quite useful in such cases, also in user constraints, where we want to have all the time, we want to have the definition of a constraint or of an attribute across all time slices, and we cannot use the day-night structure. We cannot have the time level structure there. And now we can go one step further. Let's say that I don't want a storage process to discharge on specific time slices, and I want to have that on a DINS table. So I want to have here a filter, and I say for my storage process doesn't discharge when the sun shines during the noon hours. So what I'm doing, I create my DINS table, I put my bound, I put my process, my auxiliary commodity, because this is a storage process and the bound needs to be defined on auxiliary commodity. And then I put this. I put a name on my time slice. I say my time slice is only for summer, so this is only for summer. And my upper bound here is 0, only for summer. And what I do next is that I go to the C settings file and I insert an RFS switch. And in this RFS switch, I use the $set structure, and I say $set only summer, Sunday, day and hour 08 until summer Sunday, hour 15. And this is then how this works. This means that this table is written like that in the myDD file, and GAMS automatically, when it sees the only summer, expands the only summer name with the definition of the time slices that I did. And this helps me a little bit to define a bound on time slices without listing all the time slices there. And let's have a little bit, and this is my last slide, a more complex structure. Again, the same problem. I don't want the storage process to discharge on specific time slices. Again, I just write like that. And now let's say how we can create a more complex structure of time slices. So here, my name only summer now includes time slices from Sunday, hour 1 until hour 24, Saturday from hour 1 until hour 24, and a working day from hour 1 until hour 24. So I have here a more complex structure, and the trick is that I use this star so that the GAMS expands between 01 and 24, but also I put this into a parenthesis and to a comma. So that's my conclusions. So if possible, we can use a single workbook and a data scenario file to construct DFM DINS that largely can improve the sync times in VEDA. Also, as Amit said, time slices we can put there as well. If many processes are different between regions, then perhaps instead of one workbook, maybe you have 2 workbooks, and then you can group common regions. You can map common regions to their own workbook. And of course, there is this flexibility in DINS, INS, and user constraints via the 2 tricks of GAMS, the access of all members of a set, like the time slices, for example, with this symbol and the name of the time slice set, and also that we can use the set command of GAMS in a RFS switch table in C settings file to create, let's say, some filters on the DINS table. So that's all from my side, and I'm ready for questions.
Thanks, Vangeli. I have not received any written questions so far as I can see. So.
Too complex, maybe.
Can I have a brief unwritten question?
Yeah, Alex, please.
Yeah, I just was wondering whether one could use that switch in a scenario file as well.
All these are in scenario files, yes.
In the scenario file, so that one can, for example,
sorry,
turn
the
on,
RF switch. Alex, the RF switch.
Yeah, so that one could turn on an add-on if you know, if a specific scenario file is part of the case.
Which switch? The RF? Which switch you're?
Yes.
You mean?
Yes.
Yes, Alex.
I just
actually
so that you can see.
See, there is an SF switch also, which is a scenario file switch.
Yes.
So RF switch works in the run file, and the scenario file switch would work in the scenario file where it is there. But new Veda 2 is yet to do this, support these switches. But this is very interesting. So if you have another question, you say. Otherwise, I have a comment for Vangelis. Okay, so Vangelis, your hash, that symbol is called hash in English.
Okay, thanks.
Yes. And hash PRC did not work because for processes and commodities and regions, and we have a QC. So
Okay.
the DINS, after DINS, we reject the rows with processes and commodities that are not defined. But we can. I mean, this looks like a very powerful functionality what you have created. So we can certainly allow these as internal processes. You know, like we do for a list of climate parameters. We have those created as commodities. So similarly, we can have these hash set names as valid processes, commodities, and time slices in their own dimensions.
That could be fantastic, because then we can have really subsets, in a sense, subsets to DINS.
But so I guess this would apply only to the time sets like ELE, DMD, PRE, or
this functionality applies to the time slice set very well. So whatever is defined as a time slice is supported at the moment in Veda. This works perfectly fine. So annual, weekly, day, night, and then all the combinations of the time slices that one defines in the C settings, all these are supported.
Yeah, and like you can also create a named filter, like through the RF switch.
Yes, and then you can create also a name. So for example, here you can have some filters. And at the moment, because the name can be everywhere in GAMS, it doesn't matter. It can be for time slices, it can be for processes, for commodities. But for Veda, in Veda, when you import, as you said, you cannot put the name, the user-defined name for process and commodities at the moment.
Yeah, so that's very easy to fix. That
Okay.
will do for sure.
And this also helps in something else, because it facilitates the user friendliness of the file, because usually instead through the names we can define some sort of documentation, like that I said here, only summer, and it was clear that this constraint applies only to summer. So this helps a little bit the documentation.
Yes, just I think one observation is that let's see, in Veda 2, the processing times are so different that that you may reconsider. I mean, if you were doing this in Veda 2, then probably you would not have gone for a single DINS table, because I mean, yes, it would be faster to process, but it's also more work to actually create that. You must have some kind of script to create that DINS table, I guess.
For the instances, no, I used just one Veda database.
Oh, and you exported, and then it all came as DINS.
All came as DINS, because this is something that I reserved it for another webinar. All the instances were defined at once in Veda, and I was just selecting the regions that I was interested its time. So in the region list in Veda frontend, I had all the regions there. And I selected only the valid regions, and immediately GAMS was rejecting data that are not valid for the regions that I haven't selected.
Okay. So in a way, your DINS table has been created from Veda. So you had a full version of the model in which you had rule-based, the granular tables, and then you so So the basic tables remain a part of the model in a way. I mean, you have extracted this part for rapid sensitivity analysis, but it remains a part of the model itself.
Yes, everything
because, yeah, just one last comment is that there is some amount of overlap between the native Veda functionality of rule-based processing and what you've done with this, especially with named filters. You know, this summer only, I mean, you could list the time slices in a non-dense table. You know, and with Veda 2, I don't think you will notice so much difference for it unless your inst tables are thousands of rows. It can go very fast. But that's just a comment that that there is some overlap between the native functionality and this, and of course, that's the whole point.
Okay.
Auntie has.
Yeah.
Ah, yes, Auntie has a question about the quotation marks, and will it create a problem with this hash? Because in Veda 2, everything comes out with a quotation mark. You know, the double quotes, the DD files are all quoted. So the hash thing will not work, right? Then?
Say it again. I'm sorry, I didn't hear it very well.
I will let Auntie say his question. Yes. The question is from Auntie.
It's from Auntie.
Yeah.
So please, Andy, if you can open your mic and state the question.
Yes, I was just wondering about those GAMS tricks that were presented. That they, I believe that they will not work if Veda adds quotes around the item names, because then the hash will be inside the quotes, and then it will not be processed by GAMS.
This is absolutely true, Andy. I don't know. I haven't tried that with the new Veda. It's always with the old Veda. So if this is happening in the new Veda, then it doesn't work.
Yeah, but I mean, we can always find a way around it. We can either see in the old Veda, to put quotation marks or not was a user choice. And we decided to always use quotation because it simplifies our QC of process names. You know, because if you don't put quotes, then we have to eliminate spaces and all those characters from the element names, you know. But if we use quotes, then we don't. So I think we'll try to find a logic in which we can spare these hash candidates from the quotes and keep using quotes in other places so that we don't have to get into the process and commodity and UC name QCs. You know, because right now you can have a UC name with a hash in it, with a space in it, with anything. But yeah, I mean, we'll make sure that your hash approach works. Don't worry.
Okay, good. So I think we can close this part now. Thanks a lot, Vagelis. So we can move on to the next presentation by Gary on building a new model by transforming the times Veda's data. So Gary, you can start sharing your screen and the presentation. Great. Yeah, thanks.
Good morning, everyone. Most of you know about the time starter. This is just a brief refresher. Some of it's been presented before about using it as a platform to build a new model from scratch. And to date, in the 2 years that we've had this starter route available, over 270 people have downloaded it. And out of that, I've assisted at least 24 PhD students to build models from anything from municipal to multi-region African models. And I know Maurizio has built at least a half a dozen models for Central America. And so the mechanism has proven robust, although it's certainly, not trivial. No big surprise, Veda is handling the management of these basic groups of entities. So there's a base here energy balance and load curve in a demand projection workbook, and then the breakout of existing and new technologies and scenarios, policy scenarios coming in. And then importantly, there are 2 Excel workbooks. One is a calibration check. So after you've run just a 1-year model, you can do an update Excel to a calibration workbook, and it'll show you where you're out of alignment between the energy balance and the model results. And there's an analytics graphing workbook, which I'll also give you a picture of. So again, no big surprise, but we have starter as the name of the region, and we build the various groups. So there's a supply template, a host of BY templates, and there's some dependencies between these. There's links between some of these individual templates and others. And actually, I've been thinking about, and I want to talk to Amit more about, in Veda 2.0, the no seed value or seed value mechanism, the recognition that there's a template that's using information from another template. We might be able to come up with a way to get Veda 2.0 to be more aware of that. And therefore, if you make a change to your BY template, right now, there's an Excel workbook where they check dependencies and update links, and this refreshes all of the dependency workbook. So if I was to change the commercial BY template, it also needs to change the new text and the UCs and things like that. So there is a utility that handles that, but it is the Achilles heel of this approach is these linked interdependencies. So if you start inserting a commodity or a process in the BY, you need to remember to also have your NT open and your UT open. So we encourage working basically a sector at a time when you're making those kind of structural changes to the original setup. These are the individual sheets that you'll find in all the workbooks. Well, excuse me, in the BY workbooks. So the setup, energy balance, and calibration all come from other sheets. So they come from the energy balance sheet, and the setup, for example, is automatically adjusted based upon whether you have an entry for a particular commodity going into a particular sector or not. And then the gray areas are all of the declaration sheets. They tie into this setup sheet and are dynamically turned on and off or commented on and off depending upon what's inherited from the energy balance. And then there's your source data sheets. And that's one of the key things about the starter model is you've got to do you got to come up with your energy balance and your load curve. But then there is, although it's a little bit outdated now, it's from 2016, a repository of new technology and existing technology data coming from the US EPA 9-region times model that is automatically set as a default to get you off the ground for, again, everything except your energy balance and your resids. So we start with a standard national energy balance, as I mentioned. And if a user does not need a commodity or something, or has a commodity missing, we encourage just simple editing of the names that are up top, because those propagate through into each of those setup sheets. And so you can change any name you want. However, following strict naming conventions is standard and pretty important to getting everything to work right, and move off from there. Again, this starter system is meant for new people who have basically maybe gone through the Demo S training and not much more. So we do have a base year load calibration workbook, which takes the annual hourly load curve. And then these green areas allow you to say, these are the months that I want to go and assign to summer, fall, winter, and spring. And then these are the hours that are to go and correspond to the time slices. and you get an immediate feedback on how well visually you're fitting the data from the annual load curve to the load duration curve that you're trying to build, and how well you're matching the peak. And all of that information then feeds into the sys settings and gets you off the ground. As I mentioned, the setup sheet dynamically looks at, where you have and don't have certain kinds of technologies or commodities available in the energy balance. And the setup sheet also identifies what is the sheet for the source data and what is the corresponding entity called on the source data sheet. And that's then used through VLOOKUPs to go and populate efficiencies, availability factors, and all of the generic information that's going to be necessary to build a model. In each of the sector workbooks, this is the power sector, there's also a calibration sheet where you get to go, and from the energy balance where you've said, okay, I've got this much coal coming into the power sector, you've now got to split that out so that you end up with the individual technologies that are using coal having their respective now country-specific information. And then this again carries off into the BY templates. And so here's a standard load sheet into the Veda front end. And the key issue, or some of the key things about this workbook, again, besides things being included or excluded based upon the setup sheet, up here we identify the names on the source data sheet corresponding to the attribute names that Veda is going to actually see. So if your source is not a times model or something, those things can be directly mapped. Then all of this green area is VLOOKUPs into the source data sheet or possibly into the calibration sheet for the resids and things like that. Then at the same time, in each of the BY templates, based upon what fuels you're using, there's what we call an X process. So X sector and then fuel name goes and creates the links automatically to move the fuels from the upstream to the individual sectors. Out of the demand process, we go, out of the calibration process, we end up with the first year demand projection, and we inherit the time slice information from that time slice workbook, and we set up the mapping of this sector's emissions to the overall emissions. So again, there's a standard structure that lets us go and address most individual parts of the model components. That seeded demand value for the first year is then brought into a demand workbook where you have all the standard levers of population, GDP growth, new housing build rates and decay rates, heating day corrections and things like that. So the standard tool for building, your first model are here to go and put that information in, and that then results in your demand projection. And then finally, very importantly, there's a fairly messy user constraint workbook that has 3 components to it. It has, as you can see, for this sector RHB, so heating in buildings, there's a fuel constraint, and the fuel constraint looks at the first year value and then begins to give a little bit of flexibility depending upon whether it's an upper or lower bound constraint to go and set fuel shares where you go and decide what your relaxation factor is in the last year to go and get a banded range to go and move from one fuel to another. Similarly, one of the issues you have is that based upon the performance of the device, you may have a lot of dumping of old technologies or dominance of a single device. So we have 4 classifications of new devices: standard, improved, better, and advanced. And you can control the rate at which those new devices are allowed to penetrate the system. And then finally, for certain technologies, you have a type. It may be a heat pump versus a furnace. And again, out of the calibration, there'll be the initial values, and you can control how much you allow the device type to change over time. And then in addition, there's this analytics workbook on the back end, and it's all set up to work with an array of about 40 or 50 tables that have been built in Veda backend. And these tables present then automatically update for your new scenario runs, and have VBA programming to add new scenarios and things like that. And then always produces for each of your graph sheets, it produces a standard graph, trend graph, cumulative bar trend graph for the reference scenario, a comparison of up to 4 scenarios, a difference between the first scenario and each of the other scenarios, a cumulative snapshot of what's going on in terms of, this happens to be CO2 emissions, it would be the change in generation as well. And oh, excuse me, I'm sorry, this is a metrics. So this is a cross the model horizon total CO2 for the different scenarios and what the difference is with those. And then this is the other part that I mentioned. You have the first year and a selection year, and you get to see how the configuration of the generation mix has changed, and some snapshot of how total generation may have changed within these. And we get 90% of the tables and graphs that we need for presentations and reports out of this workbook. Sometimes we have to do intermediate calculations to get percent of renewables within electric generation, but you just add those to empty spaces within the graphic workbook, and all that information is there for you to use. And that's basically all I wanted to do. What I have included in the back of this is the step-by-step process that you go through to go and actually do each of these steps, where again, as I mentioned, the Achilles heel to the approach is that there are these hyperlinks between templates. So you've got to take extra special care to remember that whenever you're making data changes that might affect the other templates. So the UCs are going to be affected if you change your resid, and the new texts are going to be affected if you add a new technology and things like that. So that's the one point in care that you need to deal with. So very quickly, basically that's what's going on. Again, I'm pretty pleased with the success it's been able to have, and for the most part, the level of support for those who get serious about building this is under a half a dozen emails, although certainly there's been some that have required 20 and 30 emails to get them to where they needed to be. So I went pretty fast because, again, I know a lot of you may be familiar with some of this, and it's not a power presentation like the interesting things that Avasio just mentioned, but I thought it would be good to just remind people of what's going on with this, and that it has really been quite successful and is quite manageable to go off and put together your model. Okay.
Thanks, Gary. So let's, we have the 10 minutes that I have promised at the end. So it's basically the floor is now open for overall questions to Gary or to the other speakers as well, if you have anything. I don't see anything in the chat, so whoever wants to or has a question, just raise your hand and open your mic. No, I don't see anything. Okay, so that makes things easier then, I suppose. So we can close it. So, I mean, first of all, I would like to thank UCL for hosting this webinar and the previous one and all this series of webinars for ETSAP, and Paul in particular for taking over the role of the host. And I would like to have an open invitation. So if any one of you has something that you would like to see in a webinar, if there's a topic that you're interested in, please send me an email or send somebody from the ETSAP community an email, and we can arrange and have a webinar on this specific topic. So as I said, we have the next webinar, which is planned for the 10th of December. We will have two modelers from the IEA who will talk on the approaches and tools for the world energy outlook and the energy technology perspective at IEA. So that will be an open workshop and a webinar, and we plan to have the next one in January, and the topic is not there yet, so it's still open. So if you have any suggestions, please send an email and we can arrange for a webinar on a specific topic. So thanks a lot. Thanks to the speakers.
George, just one quick comment on that. I think monthly might be too often. You know, maybe every 2 months might make
it depends on what kind of input we have from people. I mean, we'll see how it goes.
I enjoy the monthly.
But it's your turn next, James, so think about something. Okay? Right. So thanks a lot, everybody.
George, it would be
Alex.
At least to get info about the workshops, just like instead of only on the website, it would be really nice to get an email about upcoming seminars.
Okay.
Upcoming
make
workshops.
a note of that. Okay.
That'd be great.
Good. At the moment, we have just used the limited ETSAP list, but we'll use an extended list. Okay. Thanks. Right. Thanks a lot, everybody. Enjoy. Take care. Bye-bye.